Hi, Math 20-1 students. Okay, so today we're looking at lesson 3.3, which is going to be completing this square. So if you remember so far in this chapter, we've looked at what a quadratic function is, and then we looked at the quadratic function in vertex form. Last lesson, we looked at the quadratic function in standard form, and what we're going to do today is called completing this square, which is a way to convert quadratic functions from the standard form to the vertex form. Okay, and we're going to talk a little bit about why that would be important as well. And then we're going to work a little bit with writing quadratic functions to model situations. So that's essentially how we're going to start out, is looking at modeling situations by building up a quadratic function. So in order to think about kind of what would be a practical situation where we might be using some of this, let's take a minute to think about this investigation. So it says, when retailers consider what price to set for their merchandise, there are many factors to take into consideration. If items are priced too high, then few people may buy them. If the prices are set too low, then more people might buy it, but because they're not making much money per piece, the sellers might not take in a lot of revenue. So the key when you're selling something is to be able to find the optimum price. And so what we want to figure out is, how can you determine a price at which to sell the items that will give a maximum revenue? Now, like you probably remember, we looked at an investigation in one of the previous lessons where we talked about finding the maximum height of a football, right, if it gets kicked. And so what we find a lot with quadratics, due to the nature of the shape of the graph, is that they help us to find maximums, right? So if you think about if you were setting a price and you wanted to find the maximum, well, first of all, obviously you would start out, if you sell 0 items, then the price is going to be 0. So your starting point, if you were graphing it, would be at 0 and 0, or at the origin. And then if this is true, then if items are like low-priced ones might sell more, right? So basically what we're going to see happening is, as you increase the price, the number that gets sold is going to change. So price is going to be along this axis, and let's do that. Price and number sold would be along here. Just remembering always to put your dependent and independent variables on the proper axis. So basically what we would see is, we're going to see prices, as the price increases, we're going to see an increase in the number that gets sold up to a certain point. And then when the price becomes too high, it's going to hit a maximum where you kind of have the nice best of both worlds, I guess, like the higher price and the number sold. And then on the other side of that, we're going to see it start to decline, right? So up until you hit a maximum price where 0 gets sold. Okay, so that's our general shape for a graph, and as you can see, this is like a classic quadratic shape. So it makes sense that working with quadratics can help us to solve some of these business problems. So let's look at an example where we can work through something like that. It says, suppose that Victor is considering pricing for goalie masks. Last year, he sold the goalie masks for $400 each, and he sold 14 masks. So when you're reading these types of questions, you always want to kind of take note of what the base, like the baseline kind of set of conditions were. So he's using as a reference last year. He sold them for $400 each, and he sold 14 masks. Okay. Now he predicts that for every $40 increase in price, okay, so this is, I might even get real crazy here and use a different color. So he's predicting that for every $40 increase in price, so now we're looking at a change, so I'm using a different color. He will, so $40 increase in price, 1 fewer mask is sold. Okay, so again, we have both the pricing and the number of masks sold being referred to. So the revenue from the goalie mask in sales, or the goalie mask sales, sorry, is R of X. So revenue is a function of X. Okay, and so you would need to think about, what would X be representing there? Well, it's going to be the number of goalie masks sold times by the cost that you have per mask, right? So first of all, we have to complete the table to model how Victor's total revenue this year might change for each price increase or decrease of $40. Okay, so if you want, you can pause the video and go ahead and fill this in yourself. If you can, I'm sure you can figure out how to do that. And otherwise, when you're finished with that, you can come back and we will have our table filled in. Okay, so basically what you would be doing here is here is his baseline price, right, of 400. Now, he said that the price interval that he's looking at changing it by is $40. So if we go up from there in cost, it's going to be 440. Then the next one would be 480. The next one would be 520, right, because we're just adding 40 to each successive number. Now, if we want to figure out less, we have to subtract. So 400 minus 40 would be 360, and 360 minus 40 would be 320. Okay, so now we have a range of costs per mask. The other thing we need to figure out is the revenue. So basically the revenue is going to be how many masks did you sell at a certain price. So 16 times by 320 gives us 5,120. 15 times by 360 gives us 5,400. The other two were calculated for us. 12 times 480 gives us 5,760. And 11 times 520 gives us 5,720. Okay, so, oh, wait a minute. How does that work? No, that can't be 56, 5720, 57. Oh yeah, that works. Okay. So then they're asking us, what pattern do you notice in the revenue as the price changes? Okay, so what do you notice about the revenue as the price is changing? We start at 5,120, go to 5,400, 5,600, 5,720, 5,760, and then our last one is 5,720. So what do you think is happening there? Well, obviously that revenue is increasing up to a certain point, and then it starts to decrease. Okay, so for some of these written questions, guys, you can check the filled in notes. I have the answers written down, but I'm not going to take up time on the videos to write it all out because it's available for you there. Now, why do we think that this pattern occurs? Well, they kind of told it to us right in the question, right? Which is that people, if they're looking to buy something, then, you know, there's a certain price that they'll go up to, and there's going to be an optimal price where your number of people who will buy at that price is balanced out by the amount of money you get per unit. And then after that, if your prices continue to increase, less and less people will buy it, right? So basically we end up seeing a trend of the revenue or the price of the mask basically being balanced out by the number of masks that are actually sold because of that relationship. Okay. So let's talk about how we can actually make like a quadratic equation based on this information that we just had. So we're going to let X is going to represent the number of $40 increases, and we want to determine an expression to represent the cost of the goalie masks. So when you're being asked to do things like this, you always want to use the base information that they gave you. So if you remember, I mentioned to you the base information, or the like standard that we're working from, is selling 14 masks at $400 each. Okay, now you also want to consider what the change will be, which is that if you increase the price by $40, so starting at 400 and you have a $40 increase, then you're going to have one less mask. So if we want to have an expression to represent the cost of the goalie masks, we would start out at 400, right, was our base value. And then we can add in $40 times by however many price increases we have, right? And that's going to give us the cost of our mask. Okay, so basically just think about when you're trying to come up with that, just think about how did you actually like calculate the next one, for example. So we did 400 plus 40 and that was one increase of $40. So 400 plus 40 times by 1, which was X, right? And then, of course, if we wanted to go straight from 400 to 520, we would say, okay, well, it's 400 plus 40 times by 1, 2, 3 price increases, right? So 40 times by 3 would be 120, and so 400 plus 120 would give us 520. Okay, so you just want to make sure that your numbers, once you come up with an expression, that they make sense against the table of values that you've created. Okay, the next one says determine an expression to represent the number of masks sold. So again, you want to start at the base, which was 14 masks were being sold, and then you want to think about what's going to happen if this is the price change, right? So if we have $400 plus a $40 increase multiplied by however many times, we know that the number of masks is going to go down by 1 for each increase, right? So if we have 1 increase, which is X, then we have 1 decrease in the number sold. So basically what we're going to see is, for example, here we had 14 selling at 400. When we increase by 1, so when our X value is 1, then what happens to the number sold? Well, it's 14 minus 1, right? Which is our number of cost increases. If we go to a 2 increases, then we have that our number sold is 12, which is 14 minus 2, which is the number of increases in price that we've seen. So our relationship is basically 14 minus the number of increases that we've seen, which is X. So we can say 14 minus X is equal to the number sold. Okay. Then it tells you to determine the revenue function. And remember, they actually mentioned to us here, the revenue function is represented by the number of masks sold times by the cost per mask. And we just came up with functions that represent both of those. So we can say that the revenue function, kind of in a more specific manner than what we were given on the previous page, is going to be equal to the cost of the mask, 400 plus 40x. There we go. Plus 40x multiplied by the number sold, right? 14 minus x. So that's going to be our function. And then it asks us to expand it to give a quadratic function in standard form. So this is where you have to remember a little bit back to your previous schooling. You might have heard of the term FOIL. I don't know, I'm not sure if people use that anymore. But basically when you're multiplying sets of brackets, you need to make sure that everything inside of the brackets has been multiplied by each other. So the easiest way to do that is to do it really methodically and start out with the first, right? So you want to multiply the first by the first. So 400 times by 14 is going to be 5,600. 5,600. Okay, then you want to do the outside. So staying with this first one, which is on the outside of the brackets, and multiplying it by this one here. 400 times by negative x is going to be negative 400x. Sorry, that 5,600 is bugging me. There we go. That's better. Okay, so minus 400x. So first outside, inside. So they're on the insides of the brackets. So it's 40x times by 14, which would be, let's see, plus. So they're both positive. So plus 560x. Okay, and then the last one is last. So the last two components of each bracket, which is plus 40x times by negative x, which gives us negative 40. And remember, x times x gives us x squared. Okay, now if we want to simplify this, remember you can combine like terms, which we have here. We have an x value and an x value. So then we can say our x is equal to 5,600. Negative 400 plus 560 gives us plus 160x, and then minus 40x squared. And then the last thing we need to think is that it's asking for it in the standard form. And if you remember, the standard form always starts out with the squared value, then the x value, and then the just plain number. And so we basically want to start out with the 40x squared. Now, whenever you're doing something like this, make sure you keep the positive or negative value with it. So this was minus 40x squared. So we want to start out with negative 40x squared. And then this one is positive 160x, so plus 160x. And then 5600 doesn't have a negative in front of it, so it's plus 5600. Okay, so that is our function in standard form. Now, the other thing that we want to keep on doing, which we kind of started in the previous lessons, but we're going to carry on with, is being able to work with these graphs in your graphing calculator. So they want us to graph the function on our calculator, so we're going to go into our y equals. Okay, I'm just going to push this up here a little bit. So go into your y equals, and we want to put in our graph, right? So remember, with negative, make sure you use the proper negative button. 40x squared plus 160x plus 5600. Okay, so there's our graph. And it's asking us to figure out the maximum. So let's see what this graph looks like. I'm not sure where I last had my window settings. Ooh, okay, looks like I have to work on my windows a little bit. Let's see, I'm guessing the standard is going to be way too small. Yeah, not even close. Okay, so let's try doing, first of all, we definitely need to have our x maximum be quite a bit larger. Let's try 100 and see where that is. Oh, sorry, that was our x maximum. I meant to do y. So this one, so for x maximum, we could probably have it down to like 30 maybe. Let's see what that looks like. Okay, so even less. Let's go in and we can also set our x minimum a little bit. Let's do minus 15 and let's do plus 15. See what that looks like. Oh yeah, that'll be good. I think. Yep, there it is. Okay, so the other thing we want to do now is our maximum. So our y maximum, let's set that way. Let's do 100 and see where that gets us. Oh, not even close. Okay, so let's try, I don't know, 1000. Still not. Okay. Let's try 5,000. Oops. Actually, I'm going to try 5,700. Oh, so close. No. Let's try 6,000 then. That should get us there. There it is. Okay, so now we can see our whole graph. If we wanted to, we could make our y minimum. Well, I don't think we're actually going to need that, so let's just leave it the way it is. Okay, so the first question is, what is the maximum possible revenue that Victor can expect? Okay, so where are we going to find maximum? Obviously at the very top, right? So remember, that means we want to go second function, trace. We want to find the maximum, enter, and it's going to ask you left bound, and we're to the left of the peak, so we can hit enter. Then it's going to ask you right bound, so make sure you scroll over to the right, and then guess, enter again. So it says the maximum here is 5760 when x is equal to 2. Okay, so vertex is at 25760. Okay, and so 5760 is the maximum revenue. Okay, next question, what price would give him the maximum revenue? Well, we need to think about, what is this 2 value giving us? It's an x component, so we know that x equals 2 at the vertex. And what did we say x was up here? Remember, we said for the number of $40 increases, we would represent it as 40 times by x. So x was the number of price increases. And so basically we can say, let's see, what price would give him the maximum? Well, how did we figure out cost of mask? It was going to be 400 plus 40 times by our x value. So price will be 400 plus 40 times by 2, which is going to give us $480 is the price that he should be giving or selling them for to get his maximum revenue. Okay, again, you guys, I have this written out way better on the filled in notes, so just refer back to those for proper ways to like fill this in if you're thinking about how would you write this for like a test on a written question or something like that. Okay, at which point on the graph was the maximum revenue apparent? Well, of course, that's the vertex, right? Is where we see the maximum. If we wanted to find out this information algebraically, in what form would this equation need to be in and why? So basically, if we wanted to solve for the vertex without doing a graph or without being able to put it on our graphing calculator, what form would it need to be in? Well, if you remember the vertex form way back to a few lessons ago, it was y equals ax minus p squared plus q, right? And so what did those values tell us? Well, remember p told us the x value of vertex, and q told us the y value of the vertex. And so we would want to have this graph in, or sorry, this equation in vertex form, because it would help us to see really easily what the vertex was without having to go through the graphing. Okay. All right, let's try the next page. So vertex form tells us more information about the graph than the standard form. And in order to answer a lot of application questions, we need to analyze the quadratic equation in vertex form. But often we're not given the equation in that form, which is not great news for us. I'm not sure why they can't just make it easy and keep it all in vertex, but that's the way it is. So you have to be able to convert a standard form equation into the vertex form, and we do this through a process known as completing this square. Now, if you remember on the last lesson, I couldn't quite remember. I thought maybe you guys had done completing the square in 10C, but you wouldn't have done completing the square, but you should be familiar with something called a perfect square trinomial. And basically, you would have looked at how to factor that when you were in grade 10 in Math 10C. And so today we're going to kind of just remember a little bit of that information. So let me just see here. So what would we do here? It says expand the following into a perfect square trinomial. And this is where you'll really see what we mean by perfect square trinomial. So remember, expand is what we just did in the previous page. So it's basically if we have x plus 4 squared, when we expand it, we set it into its separate brackets. So x plus 4 squared is x plus 4 in brackets times by x plus 4 in brackets. And we need to do that same set of steps, what I called FOIL. So you take the first thing, multiply it by the first thing, that's going to give us x squared. First thing multiplied by, or outside multiplied by outside, gives us 4 times x, which is 4x. And remember, because both of these are positive, we're going to keep it as plus 4x. Then we have to do, so first outside, inside. So the inside two components, which is plus 4 times by x again. So that's plus 4x. And then last is FOIL, right? So 4 times 4 gives us 16. So plus 16. Now, we always want to, because it's called a trinomial for a reason, which is that we have 3 different components. And so we want to simplify this here so that the 2x components are always added together. So we end up with x squared plus 4x gives us 8x plus 16. Okay, and that's our perfect square trinomial. Okay, let's try another one, x minus 5 squared. So we're going to do x minus 5 times by x minus 5, which will give us x times x is x squared. X times by negative 5 gives us minus 5x. Negative 5 times by x gives us, again, negative 5x. And negative 5 times negative 5, remember a negative times a negative is always a positive. 5 times 5 is 25. And now if we simplify this, we end up with x squared. Negative 5 minus 5 gives us negative 10x plus 25. Okay, so that's our simplified version. Now let's look at this with variables, and what I want you to kind of think about as we go through this section is, what do you see as like an emerging kind of pattern that you can see or that you can pick out with these perfect square trinomials? You might remember it from when you had to factor them, but what's the relationship between these values? So if we look at, and that can be easier to see when we work with just a variable. So if we have x plus a times by x plus a, we end up with x times x is again x squared. X times a is plus ax. A times x is plus ax. And a times a is a squared. Okay, so if I want to simplify this, I'm going to have my x squared. Now I have a and a, right? And so I can actually simplify that into 2ax and then plus a squared. Yep. Okay. So if you look at that, how do you see any kind of a relationship here? So 2 times by some number, that's related to this x, or that's being multiplied by the x, but the x stays as an x, is, you can also say that a is found in this last number here as a squared value. So maybe just take a second and think, what number could a be in this one, for example? Well, if a is squared and it gives us 25, what's the square root of 25 is 5, right? And if we have a here, would it make sense for it to be 2 times by 5 in this example to give us 10? Well, yeah, it works out, right? Same thing, you can always go ahead and try it with this one as well and see if the same pattern will hold true. Okay, so just before we finish up, let's try this one. X minus a times by x minus a is x squared. And then x minus a is going to be minus ax. And then negative a times x is minus ax. And then negative a times negative a. Negative times a negative is always a positive, so we end up with positive a squared. Okay, again, we can simplify this. X squared stays the same. And then we have negative ax minus ax. So that's basically kind of the same as saying like negative minus another negative. So it's going to be minus 2, right? Like negative 1 times minus negative 1 would be, or minus 1, sorry, I guess, would be negative 2. So negative 2ax and then plus a squared. Okay, so again, similar pattern to what we see there, but in this case we are dealing with a negative, right? So it's a little bit different, but you can still see that it's 2 multiplied by the a value, and then the a value is represented in the final number by being a squared value. Okay. Now we want to think about the opposite as well, because what you need to be able to do is to go from a perfect square trinomial to the square of a binomial, which is what this is, right? Binomial is 2 different numbers in there. So how can we rewrite this as a perfect square trinomial? Well, the only way we can do it is to think about what this relationship was, right? So if we have, let's look at this one. It's all pluses, so let's compare it to this one. So what we're saying is that some number squared makes up our last number, and 2 times by that number makes up our middle number here. Okay, so the math we can do to figure out what that value is what is the square root of our last number? So square root of 9 is 3. Okay, and then we also want to think 2 times by something gives us 6. Well, we know that that's going to be 3, right? So you can see that these two numbers are the same, the one that we square rooted and then the one that we multiply by 2. Okay, and so basically, and then also you want to think, right? So 2 times by positive 3 or negative 3 to get positive 6. Well, it has to be positive, right? The square root is a little bit trickier because technically when we square root a number, we say that it could be plus or minus 3. So you have to rely on the b value, or sorry, I shouldn't start introducing those terms yet. You have to rely on this value to determine whether or not your number, your a value, should be positive or negative. Okay, so in this case it's plus 3. So basically then what we would say is our binomial is going to be x plus 3 squared. Okay, now at the beginning, if you wanted to double check that you know what you're doing, you can always try it out, right? X plus 3, x plus 3. So we're just going to confirm that this is the binomial that comes from this one. So x times x is x squared. X times by 3 is plus 3x. 3 times by x is plus 3x. 3 times by 3 is plus 9. And we end up with x squared plus 6x plus 9. Okay, which is what we started out with. So we can confirm that this is an appropriate binomial to represent that trinomial. Okay, all right, next one here, x squared minus 4x plus 4. So again, we want to follow through the steps here. What's the square root of 4? Well, it could be plus or minus 2. Okay, 2 times by what is going to give us, now remember you have to keep this value with it, so the value we're looking for is negative 4. Okay, the negative goes together with it. So 2 times what gives us negative 4? Well, it has to be times by a negative 2 to get to 4, right? So our value is negative 2. And so if we just have x squared there, then how we're going to write that is x minus 2 and then square the bracket. Okay. All right. What about this one here? We have x squared minus a quarter x plus 1/64. So this probably seems a lot trickier because students usually don't love working with fractions so much. But don't forget that just because it's a fraction, it doesn't become any more scary. We are looking for the square root of 1 over 64. Square root of 1 is 1. Square root of 64 is 8. And so we're looking at 1/8 here. Now the other thing we want to think here is 2 times by, we just want to confirm basically, because I think by now you guys realize that this number is always going to be going in here. Is 2 times by 1/8 going to be equal to negative a quarter? Well, 2 times by 1/8 will be equal to a quarter, but it has to be negative 1/8 in order to make it into negative a quarter. Okay. All right. Okay, so basically now we would just write out our binomial as x and then minus 1/4, and we want to square that bracket. Okay. And if you wanted to, you could do the confirmation just like we did for that first one to double check that you would end up with the proper number values, but it should all be good. Okay. Okay, so let's go ahead and work through a problem like this. So basically, we're going to start looking at how we can actually complete the square. So we're given y equals x squared minus 8x plus 5. And so basically, we'll go through the steps that we can do to make this into completing the square, which is going to convert this, which is standard form, right? Remember, it's standard form is always ax squared plus bx plus c, and we want to convert it into vertex form. So we're going to use some of the skills that we just learned in order to complete this. So the first step is that you want to make sure that you've grouped these first two terms together. So it's kind of a weird thing to just have as a step, but x squared minus 8x, it really does help you to keep things together as you move forward with the next set of steps. So the next thing is to find the number that is half the b value. So remember, b is this value right here, and then we want to square it. Okay, so let's start out with that because there's more stuff we need to do. So our b value is negative 8, or 8, let's just go with for now. And we want to find out what is half of that. So 8 divided by 2 gives us 4. And then, now this is why I didn't really worry too much about the negative, because then we need to square that number. So we got 4 was half of the value, and then we want to square it. So 4 squared is equal to 16. Okay. So basically now we have a number that we're going to add into our equation. So our equation is now going to be y is equal to, I want to keep the brackets that I added in there, x squared minus 8x, but now we want to add and subtract this number to here. So within the brackets, so add it to the value to the values in the brackets. So we're going to do plus 16 minus 16. Okay, and remember the reason we're doing that is because we can't just change this equation. So if I just add 16 to this, I'm changing my whole equation. I still want y to be equal to this value. So by subtracting the 16 off, what I'm actually doing is making sure that this 16 I've added in is being balanced out, right? By taking it away, so I have a 0 net change to my equation. And then I just want to add on the last piece that I had here, which was plus 5. Okay, so then the next thing is group the perfect square trinomial inside the brackets. So what is going to be the perfect square trinomial out of these? Well, remember that our squared number is always going to be positive, so this is the component of the parts that I just added that I want to keep inside the brackets. So I'm going to say, okay, y is equal to x squared minus 8x plus 16. Okay, and this 16 can get kicked out of the brackets now. So minus 16 plus 5. Okay, and then the next thing is to rewrite the perfect square trinomial as the square of a binomial. So this is where we're going to do what we found out, like what we learned about in the previous section. We're going to take this perfect square trinomial and make it into the square of a binomial. So basically what we need to do there is say, okay, our last number here is 16. So if you remember that, this is our perfect square trinomial. The square root of 16 gives us plus or minus 4, right? Because we can square positive 4 or negative 4 to get 16. Now the other thing we want to do is 2 times by what value is going to give us the b value. So our b value is negative 8. 2 times by has to be negative 4. So remember, it's going to be this number, but you just have to choose positive or negative when you do this section. So it's going to be negative 4 will be our value. So remember, all that means is now we can rewrite this, instead of as the expanded form, we can write it as its simplified binomial form. So we can say y is equal to x, bracket x, and we just figured out that our value is going to be x minus 8 to complete our binomial, and then we're going to square that, right? Now that we have that, we still want to keep the rest of this equation on there. So it's going to be minus 16 plus 5. Okay. Okay, so there's my values. And then the next thing I want to do is, to finish off here, is to simplify my equation. So I don't want to have multiple numbers being added or subtracted. So I can say y is equal to x minus 8 squared. Negative 16 plus 5 gives me negative 11. Okay, and so now I have my vertex form, which remember is a, well, a would be out here, so it's kind of not really anything. And then this is going to be my p value, which is my x coordinate of my vertex, right? And I have my q value, which is my y coordinate of my vertex. And so now I have this equation, right? Y equals x squared minus 8x plus 5, which we can't really tell a lot of information about. Now I can tell where my vertex is. It's at positive 8 on the x-axis and negative 11 on the y-axis. Or sorry, guys, I put in the wrong I put in the wrong value here. It should be 4. So don't make that confusion. I did the multiplying by, but it should have been this number. So x minus 4. Hopefully you guys caught that well before, but this is the problem of not teaching in front of a live class, is that I don't catch those mistakes until I see them later. Hopefully I catch them. Okay, so yeah, so actually, sorry, it'd be positive 4 on the x-axis and negative 11 on the y-axis. And so here you can actually see a picture of that graph. Now, the other thing that we have here is, yeah, the vertex is giving us some of that information, and also because we had a positive, like we didn't have a negative value here, we know that the graph is going to open up. So this form is going to help us to figure out a lot of different things about the graph. All right, so... oh, that was the previous page. Let's move on and try one more. Okay, or 2 more. So complete this square for y equals x squared plus 6x minus 7. Okay, so going through the same set of steps, and honestly the best way I think to practice something like this is just to try and do it over and over again without looking back. So that the procedure becomes really familiar. So remember, the first thing that we want to do is we want to separate our first 2 terms here. So y equals x squared plus 6x, and then close the bracket, minus 7. Okay, so now we know which variables we're working with to make this binomial. So basically what we want to do next is figure out how we're going to add our c value there, right? So what number are we going to add to this? And in order to figure that out, we need to know what half of this value is. And so you can probably remember this from the first part that we were doing. Half of this, half of 6 is going to be 3. Okay, and then 3, we need to square it, because if you remember when we did this part here, right? We have our a value times by 2, so that's why we're dividing it in half to figure out what a is. And then we need to square that number to figure out what c is. Okay, so just remembering why we're doing that. So 3 squared is equal to 9. Okay, so now I have my value, and basically then I can add that into my equation. So remember, I have to add it and subtract it so that I'm not changing the number value of my equation. So x squared plus 6x plus 9 minus 7. Okay, now for some of you guys, if you're really comfortable with this, you can combine some of these steps. Like personally for me, I know that I'm going to have to bump that outside, so I might do that right away. But if you prefer to keep it stepwise, especially because we will start to look at ones that get a little more complicated where you can't just bump that out right away. So you might not want to get into the habit. It depends. Maybe after this lesson, you can kind of make up your mind about that. So we have x squared plus 6x. Now to complete it, we have positives. Our squared number has to be a positive, so it's going to be plus 9, close the bracket, minus 9, minus 7. Okay, and then the next thing I want to do is figure out how can I make my trinomial into a binomial. So remember that in order to figure that out, we need to know what is the square root of the c value, which is 9, so it could be plus or minus 3. And then 2 times by what value is going to give us positive 6? Well, it would have to be plus 3, right? So plus 3 is going to be my value. I'm not going to make the same mistake I made last time. I'm going to do y equals x plus 3. Okay, not the number that we got here as our b value. And then we're going to square it. And then this is where you can kind of combine as well, right? So if you wanted to, you could keep this as negative 9 minus 7, which gives us minus 16. Okay, so you can simplify and just do that in this step instead of doing a whole extra step if you want. And then, so what does this tell us, right? We want to think about that. Well, we know that our vertex is at, keep in mind, what does this mean? If we have a positive 3 here, that means that we're going to have negative 3 as our x value, but the values don't change for these values here. So for negative 16, our y value is going to be negative 16. Also, we don't have any kind of a negative value out front here for our a value, so we know the graph is going to open up. So we can always do kind of like a rough sketch. Let's see, what are we at? X -3 and -16, so it's going to be kind of something like this. Okay, so that's going to be like the very roughest general shape that we'll see for our graph. Obviously, I did not, put out my finest artwork for that. Okay, so last one here, complete the square, -3x² minus 18x minus 24. Maybe think a second. Can you see what here is different from the previous examples that we've tried like this one? So hopefully you can see that in this one we have an a value, and it's a negative value, so it's going to be substantially different because there's a number value and it's a negative. So let's go through and see how we would work through a question like this. So first step is exactly the same. We're just separating things out. Y equals bracket -3x² minus 18x minus 24. Okay, so we've isolated these first two. Now the second step here, and again in the filled in notes I wrote this out nicely for you guys so that you can look back on it, but basically what you need to do is factor out as much as you can. Essentially what you want to usually try to do is get it so that you just have the x² and no number value here. So if we wanted to divide out a number out of both of these terms, then and that's the other thing. If you might remember from factoring that, like technically you could factor the x out of both, but we don't want to do that. Okay, so we just want to factor out number values. So if we have 3 here, we want to factor it out, -3 here. Then we can divide it out of 18 as well, right? So that's going to work out well. So we can say, okay, y is equal to, so essentially what we're doing is all of this divided by -3, so that we're left with the x² here. Okay, and then we'll have a number value here. So if we're factoring it out, it means we're putting it outside of the brackets. Okay, so it still has to stay there. Again, we don't want to change the number value of our equation. So -3 divided out would leave us with x² here. -18 divided by -3 gives us +6x. Okay, and then minus 24. Okay, so we've factored this component out. Now we can do what we would normally do in the second step, which is to determine what the third value is to make this a perfect square trinomial. And so remember that just means we're going to do what is half of 6. So 6 divided by 2 equals 3, and then we want to square that, which gives us 9. Okay, so now our perfect square trinomial is going to be y equals -3 bracket x² plus 6x plus 9, and then minus 24 at the end. Okay, now what else do we have after that? Okay, so now we have our perfect square trinomial. What's the next thing we want to do? We want to get this 9. Oh, sorry you guys, I forgot to do +9 minus 9. Full of shortcomings today. Okay, so +9 minus 9, there we go, minus 24. Hopefully you guys caught that one before me too. It's the end of a long day. Okay, so +9 minus 9. Now here's what we need to do, right? We need to get this -9 outside the bracket. But the problem is, because we've put this 9 in a bracket that's technically being multiplied by this number, in order to keep these values as even, the +9 and -9, because the +9 is technically being multiplied by -3, so the -9 has to be multiplied by as well. So in order to move that out, we need to multiply it through. So we have y equals -3 x² plus 6x plus 9. This one we don't have to multiply out ahead of time because it's still in the bracket that's being controlled by this 3. But because the -9 is moving outside of it, we need to maintain that relationship. So -3 times by -9 gives us +27, and then minus 24 stays there. Okay. So let's see, what were we normally doing in step 3? It was just that, moving the 9 outside, right? So in this one we did that, but we just altered it. Then our next step is to make our trinomial into a binomial. So we can say y equals -3. Now remember what we're doing here is the square root of 9 which is plus or minus 3. And in order to make it to positive 6, we would have to do 2 times by positive 3 to get to 6. And so our value that we need to use inside the brackets is plus 3. So it's going to be x plus 3 squared plus 27 minus 24, which gives us plus 3. So I'm going to kind of condense those steps again. And so now we have our function, and we can see what would our vertex be. X value is going to be negative 3, and y value is going to be positive 3. And this negative a value, so the 3, remember, tells us that the graph is going to be narrower. The negative tells us that it's going to be pointing down. And our vertex is going to be at, let's see, negative 3 and positive 3. So it'd be kind of like this, negative 3, positive 3, maybe kind of something like that. And then because of the number value here for the a, we're going to make it a little bit narrower than our previous one. And it's going to look something like that. Okay, so hopefully that was a fairly straightforward introduction to completing this square. You guys have a couple of questions to work on in the textbook that you can use to practice these skills. And just remember, we aren't quite finished with this section. So next lesson, I've divided this section into 2 parts. We're going to look at completing the square a little bit further, so getting into some more detailed word problems and things like that. Okay, so I will see you in that lesson.